Okay. Now, we are about to hit the big one. This is the big one. We have learned about objects. We've used objects. Lists are objects. That whole like reference alias thing, that was relevant here. But now we're at a point where we are going to make our own objects. And this is a big one. This is a very big one. This is like, of all of the new key things we're going to learn, this is the last, this is the big one. And I would say, for lack of a better term, the magnitude of this concept is much bigger than the magnitude of any of the concepts we've learned so far. So this is a big one, all right? Objects. We know what they are, but let's talk about them. So objects are a way to combine data and functionality together within our program. So it provides a way to combine data and functionality. Usually we actually don't like doing that in practice, but that's part of the spirit of what we're doing here. So motivation for this is it may help with abstraction and encapsulation. You may find it a little bit more natural and analogous to how you think about things in the real world, although this tends to be a recipe for disaster when it comes to modeling a particular problem, but in general, when learning, this isn't fine. So consider the lists you've been using. These are objects. Someone wrote these objects. Someone defined them in a way that we're about to define our own objects. Lists obviously store data, and they also have some functionality associated with them, methods, like append and remove, and there's a lot more. So we've combined data and functionality into the same entity. Right? I can tell a list to append something to it. I can add data to a list that can be retrieved later. Okay? Somebody defined this object. In the same way that somebody wrote the print function, someone defined an object. So when we define a function, when we define a variable, we are defining a variable and it's something that stores a value. We can define a function, well, that's how we define some functionality we care about. We can also define an object, which is some combination of those things together. Now, another thing too about lists, consider the fact that I can have two different lists, two separate lists. One list with the value ABC, and another list with the value 1, 2, 3. They're both lists. They both contain data. I can append to either of the lists. But if I append X to the first list, I would have ABC X. If I append X to the other list, it would be 1, 2, 3, X. They operate independently. They're both lists. They both have a size. They both have data. They both have functionality. But they're separate. You are all people. You all have a first name. You all have a first name. I'm pretty sure. But what's your first name? And what's your first name? And what's your first name? They're different. They could have been the same. Didn't matter if they were or not. But the point is, you all have first names. You all have a height. You all have a shoe size. You all have a hair color. But the values associated with these features are different. And that's normal. So you're already used to working with objects, but you've never defined your own object. So in this topic, the basics of how we define our own object will be covered. And don't get me wrong, this is very basic. But it's going to be important that you're paying attention because this is a big one. So classes versus objects. Sometimes these words are used interchangeably. Technically, there is a difference. I will almost certainly use them interchangeably by accident, but I'll do my best. I'll define the difference, but then just know that most people kind of use them interchangeably, kind of like arguments and parameters. There is a difference, but So classes versus object. We're going to make a circle object. We are going to define circles. All right? In order to start making our own object, though, we must first define a class. A class is the code that defines what it means to be a circle in our universe, that is our program. So, for example, we are going to define a circle class which contains all the information Python needs to go and make an instance of a circle. A class is effectively like the blueprint. We define a function. That's just the function definition. We call the function. Oh, okay, there we go. We define a class. A class is just some static information. This is what it means to be a circle. Then I can go make instances of a circle. List is defined somewhere in what we call a class. And then we can go make instances of this class. We can make individual lists based on how it's defined over here. I go look up the blueprint. This is how I make a list. Perfect. Each of those instances of a class are called an object. That's the difference. The class is the definition. An object is an instance of the class. But a lot of people will use these words interchangeably. Yeah, there exists a class definition, blueprint for lists. With the one class, I can then create as many instances of lists as I want. So just like the rest of the class, we're going to learn by doing. In other words, we will define a circle class and make a few instances of the circle class. However, what the hell does it mean to be a circle? We want to make a circle class. Okay, great. What do we want to do in it? We get to make this up. We are God in our universe. That is our program. We are creating everything that will exist within the program as it's running. So we get to decide what is a circle for our needs. Depending on your needs, this might be very different. So it turns out we get to invent it. We decide what the data will be stored. So what data do we want to store with our circle? And we want to define the functionality we want to have associated with our circle. For our needs, we will have a circle, 1, know its own radius. This is what we call an attribute. This is the data. Now really, this is all you need to define a circle. This is the radius of a circle. Now you've got a circle. Great. So it'll have some data. And the data associated with an instance of a circle is called its attribute. Depending on your programming language, they use slightly different words here. But it is like a field, an attribute, an instance variable, whatever. It's some data associated with an instance of a circle. And we want to be able to have some basic geometry calculations, like maybe like area and circumference or whatever, right? Why? I don't know. For our needs, this is what we need. These are what we call the methods. The functionality are the methods. They're just functions. But we call them methods because they're associated with an instance of, they're associated with a class, specifically an instance of a class, and you would tell an instance to do something. So to start the class, we use the class keyword. I'm just going to copy this. Go here. If I hit run, it's going to be mad because I have an indentation without anything under it. Apparently not. Apparently the comment's fine. I guess I don't need anything in there. Actually, I know. Never mind. Ignore. This makes perfect sense. I'm saying class circle, colon, indentation. Yeah. Good observation. Whenever you are defining a class, you start with a capital. That's why when you saw lists, it always started with a capital L. It's a class. Anything that starts with a capital is a class. It was defined in a class somewhere. Very good observation. And we would write these things in camel case, not snake case. Snake case is when you use the underscores. Camel case would be like circle is like this or something, right? Where you, what?
That's Pascal case.
Well, maybe because it starts with a capital C. Is that the difference? I don't know. So there we go. Circle, uppercase, that's how we go. I here include a docstring defining the whole class. What is the class? I'm going to delete it here for brevity, but you would typically want a docstring at the top of your class describing what it is. Oh, now it's mad. Interesting. Yeah, but, I mean, that'll fix it, but that's interesting. Anyways, the above example contains the start of a class. There's nothing there, although technically Python goes and adds stuff in there for you, but we don't see it. That's fine, we'll talk about that more later. We are defining a class. Anything indented under this is part of that class definition. So if we're indented, it's part of the class definition. In the same way that if it was indented in an if, it's in the if. In the loop, it's in the loop. In the function, it's in the function. Indentation, it's indentation. The docstring comment is a simple description of the class. Now, with just this, we can go make an instance of a circle. We can go make it a circle class. Here, let me restart the runtime. Restart session, yes. Come on. If I were to go say like, if I run this code, I'm saying, I'm making a variable called SumCircle, and it is going to be equal to a circle. This is a very simple example so far. So if you're like, this isn't very interesting, I know. And then I'm going to say print out the type of SumCircle. Now, I restarted the runtime, meaning this box has not been run yet. So I haven't truly defined what a circle is yet. So just to prove that after I do that it will work, let me show you how before I hit run this should not work. Circle is not defined. What the hell is a circle? Well, let me run this box. Now I can run this. Oh, it's a circle. Now you'll see some extra stuff in there like, oh, well, main circle. Let's not get too far into that right now. It's a circle. We ask, what's the type of circle of some circle? It's a circle. So I can create an instance of a circle now. And I can confirm that it exists by 1, using it, and 2, getting its type. And its type is a circle. Any questions so far? And yes, this is a very contrived, simple example so far. You might be saying, what's the point? What could I possibly do with this that's useful? Like nothing yet. This is literally, I made the most simple object possible. I said, circle, you can be a thing. And Python's like, okay. What data is associated with it? Nothing. What functionality is associated with it? Nothing. It's just, it can exist. Now, when I called this, despite not seeing it, Python did actually go add some functionality to this class for us. In the same way, you know how like if you don't write a return at the bottom of your function, Python sneaks in that in there and you never really see it, but it's actually there. Python's doing the same thing, a very, 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 very similar thing here. It's sneakily adding some information to your class despite you not writing it. And it just gives you some of these things there by default. And there are reasons why it goes and it sneaks this stuff in there by default. There's a long list of reasons. We won't get into them right now. That's more of a discussion for 162. But it goes and adds a bunch of things. Long story short, it makes everything work. If we can assume every object, every class contains some base functionality, and that it's going to exist, then we're good to go. We can do a lot with that. Now, the base functionality it gives you is absolutely basic, and is not very helpful. I'll show you an example of some of the basic functionality we get. Print some circle. Oh, circle object that OX7B37F, right? It gave me some functionality. I said print out that object. And it's like, okay, well, whenever you print out the object, just show them this crap. By default, show them this crap. Maybe this is helpful to you, maybe it's not, I don't know, but that's what it shows you. So that's like the default behavior. One of the default things it gave you was what we call, and this is big, the constructor. Technically in Python it's called the initializer, and it's a little bit different than a constructor, but ignore that. It's called the constructor. The constructor is a super special method that gets called whenever you create the instance of the object. Basically, when I call this, it actually went and ran a super special method called the constructor. And it has all of this important setup code on what it means to define and set up your circle. As you can see, it doesn't look like there's any special method called a constructor inside my class definition. It's not there. It's because Python snuck it in for you. It's great and all that it gave us a default constructor, but we're going to do what we call overriding the constructor. You basically tell Python, thanks, but we're going to use this one instead. Basically, ignore the default one and use this one. Pardon me. Okay, it's not particularly useful, as we have yet to really describe the circle class. So we create a constructor. To start making a class useful, we will write a special function that tells Python how do we actually want to set up our class. So here's what we're going to do. I'm just going to copy this. Nope. Add it to my class. In order for this to work, I'm just going to get rid of this. There. I have to rerun this, otherwise it won't know. So I reran this cell, and I redefined my circle class with my own defined constructor. You will notice the constructor has a very interesting name. That name is underscore underscore init underscore underscore. Then we have parentheses like any other function. But it has a super important argument in there called self, which is weird. And we're going to talk about this. And then inside, I'm saying self.radius equals 0. All right? So now, let's see how I have it laid out. Okay, the above is an example. We use init. Warning. And I'm giving you this warning. Remind me to warn you in like 5 minutes. Before I move on to the next topic, remind me to explain what the warning is. There's 2 underscores there. Underscore, underscore. Sometimes people call these things dunder, like double underscore. I kind of hate that name. But underscore, underscore, init, underscore, underscore. That's very important. If your function does not have this name, method does not have this name, it's not a constructor. It has to have this name. Otherwise, it's not a constructor. People ask, well, how does it know that's the constructor? Because by the definition of Python, when you write a function that is called underscore, underscore, init, underscore, underscore, that's the constructor. That's how you define the constructor. If you give a function that name, it's the constructor. All right? So, this is the method that runs whenever we make an instance of a circle object. And I will prove that to you right now. Print I ran. There. And when I hit run, I'm going to get rid of these 2 lines of code here. When I call this, when I call the name of the class with the open close parenthesis, it actually calls this right here. That's what it calls. All right? I ran. And we can print out, let's just see what the radius value is. It's 0. Great, cool. So like, I'm just showing you that like this gets run there. In fact, when I hit run on this, what do you expect to see? Is that what you expected to see? Because it better have been what you expected to see based on everything we've seen so far. If you're wondering, well, why did we see it twice? I called the constructor twice because I made 2 separate instances of a circle. I didn't make one instance and have 2 aliases to it. No, I made 2 entirely separate instances. And I can prove this to you even by just showing you print circle. When I hit run, these numbers are different, and that's basically like where that is stored in your computer, more or less. So because they're different, I know that they are actually separate things. I can do the first and the third one are the same because I've created an alias. Cool, cool, cool. Any questions so far? I've barely scratched the surface of the constructor. I just want to make sure what I've shown you, if there's any questions about what I've shown you specifically, ask now. All right, okay. In the above example, we see the use of a special function called underscore underscore init underscore underscore. Here's that big warning. Be careful. It's not underscore underscore int underscore underscore. It's init, the number of times I, and I'm willing to bet so many programmers accidentally write underscore underscore int. They miss that second I. And I blame the autocomplete in like your text editors. And then you're like, there's no constructor. You're like, what it is, it's right there. And then you're like, it's because you're missing this tiny little I. So just be very careful about like, did you actually call it underscore underscore init underscore underscore? Anyways. All right. So we also see what we are creating. We're creating an attribute called radius that will have a value of 0 upon creation of the circle. You will notice a special variable in there called self. And it was used before the attribute self.radius. Now, self tends to be a concept that really throws off people at your stage. And trust me, it makes perfect sense. If you keep in mind, I'm going to explain it. And it will make sense more and more and more as time goes on and you get used to working with it. But it is a little weird, I get that. But it makes sense if you realize everything's a reference. Okay? Okay, self. Self is a reference variable to the current thing, the current instance. Okay? All methods within a class require that the first parameter in all methods in a class start with self. It actually doesn't need to be called self. As long as you're consistent, it's fine, but you call it self. If you don't call it self, the Python police will come after you. Pardon? Of course. That's a stupid question. Specifically, they're Pythons. I should have said cobras, damn it. All right, all methods of the class require that the first parameter is self. You'll see countless examples of this, that'll make sense. Additionally, accessing any attribute or method from within the class must be referenced, or must be done through the self reference variable. Self variable can feel a little weird, but it's something that will start to make sense as we go. With an it written, with the setup and the blah, 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 we can do this. Yes, let me show you here. Let me show you one last thing before I go into a little bit more detail about self. Do I have? Okay. I'm going to get rid of this. Here. I'm actually just going to copy this code. There. Oh, I'm going to get rid of the IRANs from the constructors. There. So, what am I doing here? The first two lines of code, I created circle A, circle B. They are both circles. They are independent, but they are both circles, meaning they both have a radius. And upon creation, what is their radius? 0. How do you know? Exactly, because we said that literally right here. Whenever it's created, it gets an attribute called radius, and it's assigned a value 0. But then immediately on lines 4 and 5, I say, well, circle A, your radius is actually going to be 1. Okay. And circle B, your radius is 5. Okay. And then I can go back and be like, hey, on line 7, 8, circle A, what's your radius? Circle B, what's your radius? It knows. Yes? No, it won't. And that's a Python thing. If this was a more strongly typed language like I would prefer, it would be like, what are you doing? It's got to be an integer. Yeah. So, do we have any questions about this? At the end of the day, all I'm showing you is, if you're thinking to yourself right now, okay, it's like a variable with extra steps. Nailed it. 100% correct. That's exactly it. Now, keep in mind, I can add additional attributes. Like I can do that, and then like I can have like, okay, circle A, what's your radius and your, I don't know what this is. Like I can do as many attributes as I want. But you could almost think of it as like, okay, it's a variable, but okay, it's a variable, but it's like categorized. We have an object, and then that object has individual like characteristics. Oh, like the people example we talked about. You all have a first name, but maybe the values are different. At this stage, though, it's just variables with extra steps. Now, let me circle back to, to the self thing. All of the values must be accessed through their reference variable. So, let me try to draw this. When on line 1, I say circle A is a new circle, okay? And that calls the constructor. And that constructor, if we remember, as we see on line 4 in the previous cell, radius is 0. Self.radius is 0. So it's not like, oh, some variable named radius is 0. No. It is a variable specifically associated. So each object has a special variable in it called self. There's an S there for those of you sitting far away. It has a variable called self, and that variable is a reference variable to itself. This is important. If you're like, why? It is. At this stage, the best I can tell you is it is. It's important. And then I say, okay, self, hey, oh, me? My radius is 0. Okay? Then, on line 2 of the second box, I go and create another circle. That circle is over here. It has a reference variable called S, and it has a reference back to itself. And it has a radius of 0. And let's say I just have this as A, that's circle A, and B is circle B. So now let's do a little exercise. On line 4, I say circle A dot radius is 1. Circle A, well, that's this whole circle. Your radius, we set it to 1. Okay? In this moment, and like at this instance, self is like an alias for A. A is an alias for self. But then when we go down to line 5, in the context of this circle, self is a reference to, well, an entirely different circle. They're like aliases for each other. And I say your radius is 5. There we go. Okay? Not okay. Do you have a question, or are you just making a statement? Okay, we're going to see an example very shortly. I don't know if we'll get to it today. We're going to get an example later, very soon in the course, that I think if you are okay with this, great. If you're not okay with this, there's an example where I think it will make things kind of come together. So if you're still not okay with this, to be clear, I didn't understand this concept really until I was in like the second half of my second year. Now, you guys had a lot better of a prof than I did. So, you know, you'll probably get it before that. But it is a weird idea. But in the example I'll show you later, I think it helps clarify things. If your issue is, I don't see why this is necessary, that's different than understanding what it's doing. You can understand what it's doing and be like, but why? At that stage, that's fine. But if you're like, I don't get it. In the context of when I talked about A, what is A? Well, A is a reference to this circle. And within that circle, S is a reference to itself. And I need to access any of the fields, the attributes, any of the values, specific data points in here. I need to access it through a reference to that object. It would be like saying, I have a reference to you, and I'm like, what's your first name, right? And for you to answer that, you would say like, oh, myself. What is my first name? When I'm pointing to you, I'm referencing you. And then you have to say, okay, well, my. That's still you, right? So it's all relative. When I'm looking at you, I'm asking your name. You go like, what is my name? My would be like the self, right? It's like an internal reference back to you. That's what it's doing. Yeah?
Self be used outside of classes?
No. Self will only ever refer to an instance of that class. So every circle has a self, but what it references can only ever be like itself, unless you definitely try to break things, and don't do that. Yeah? Dot radius is not a method. It's like a variable. And the reason we know it's not a method is there's no parentheses. So if you're saying, did it already exist? It only existed after I did this.
Okay, so that's just create.
That's like defining, right? So if I do this, and like check this out. If I go down here and I say circle, it already knows, right? Oh, dot radius. If I go back here, don't ask me why, and I hit run, and I go circle A dot, well now it's like, oh, well there's a Schmadius, right? but it's only data at this point. There's no methodology associated with this other than the constructor.
So that just adds a value for self.
It's like, I'm like defining what are the attributes about this class that I care about. You have a first name, you have a last name, you have a eye color, you have a nose shape, you have a whatever. That's what I'm like defining right now. That's all it is. Like I said, it's like variables with extra steps. Yeah.
Can you do something stupid and be like circle a dot self dot self dot self dot radius equals 8, or is it going to have a hard path?
Well, self. I've never tried this. Looks like it's just kind of like, what do you, well. It's not, self in and of itself is not an actual attribute of the class, so we can't access it through that. It's just a reference variable. I should have known that. You had me wondering, though. It was a fun question. Other questions? If you don't fully understand self at this point, you're remarkably normal. Yeah?
When we're defining self.radius equals, can there be an expression or some sort of calculation assigned with that, or does it have to just be a value?
It could be a calculation. Well, let me show you the next thing, and you might be content.
You said circle a dot radius equals 99, and it's just like fine with that, even though circles don't have much radius right now.
We may have added, well, let's see what happens.
Yeah, like is that just its own variable called that, or is it actually part of the circle?
Do we rerun this, though?
Yeah,
I'm guessing we can add fields on the fly. I don't think I've ever done it like this before. This is pretty, that's weird. If a language is going to let you do it, it'd be Python. I wouldn't recommend just going to add attributes on the fly. Restart. I guess that makes sense in Python because things don't need to be defined beforehand. I wouldn't recommend doing this. This would be a big, like, a weird design thing. I'm just going to restart the session to make sure.
Do you think you could do something stupid like that with defining a method inside of the object?
Yeah, you could probably, well, I don't know how you'd be able to, no, you must be able, you would, I would imagine you could do that in the same way, but you would have to have it equal some method. Yeah. Yeah, don't though.
No.
Yeah, don't do this. For various reasons that will hopefully become clear as we continue. So, look. This is kind of annoying, right? Okay, it starts at 0, then we assign the values. Well, yeah, but what we could do is we could say, okay, great. Yeah, so look. Instead of like just setting the radius value to be 0, we can actually go and add self radius. There. And now when I call this, it's going to crash. Because it's going to say, no, you're supposed to give me a... Now this is where it's a little weird. You're supposed to give me one positional argument. And you're looking at this and you're like, but there's 2. Self doesn't count. You ignore, it like doesn't count self. Self must be there. So I could say like 6 and 6. Now when I run this, we see 1 and 5. That's because I immediately overwrote them. So let's get rid of that. And let's get rid of these comments because they're lying. And I hit run, and now we can see the radius values are whatever I specify here. So that's a little nicer. Two big things here. The fact that this is called radius and this is called self.radius. Two key things here. One, this could be called whatever I want. It's entirely fine. They did not need to match. Now, I'm going to go back to this because that's just a good name for it. But they don't need to match. The second thing to note here, radius and self.radius are two entirely different things. Radius is just a variable holding a value. Self.radius is my radius. Okay? Okay? So self.radius is the radius of the circle. The variable, the parameter radius, is just the name of some parameter. They have the same name, but they are entirely different. Entirely. Okay? Okay? This is a big one. So there we go. Now, if you wanted to answer your question really quick, this would be obviously not workable for the, like this would be a bad decision if I was trying to make a circle and divide it a radius. I can make this times 88 divided by 5 square. It can be a calculation. All it needs to do is evaluate to some individual value in the end. Obviously, this is ridiculous for the purposes of our circle, but here I'm just assigning it to another variable. It just could, anything that is a value that's like correct. So any last questions before you wrap up? All right, I'll see you all later.